Seniors, this marks the last time you will take notes in a high school math class. Are you gonna be okay? You gonna be okay the last time? Gonna be okay? Okay. All right. If an object is launched with initial velocity at an angle with initial height, then the projectile follows the path of x equals initial velocity cosine theta t and y equals negative 16t squared plus initial velocity sine of theta t plus initial height. For right now, just write it down. Just write it down. Is there glare?
Yeah, a little bit.
Okay. The sun's actually out. It's so fantastic. I watched a soccer game in short sleeves yesterday. First time all year. Okay, so it seems like you have most of this written down. Let's talk about what the advantage of this is, okay? So back in Algebra 2, you probably remember working with an equation that looked like this. Y equals negative 16t squared plus velocity t plus height. Okay, and you could figure out the path of the projectile in terms of either time and height or horizontal and height, okay, but never both at the same time. So this is what this allows us to do. We can separate our horizontal distance from our vertical distance and analyze them in terms of time. So I can plug a t in for time and figure out how far the projectile has gone horizontally and how high it is off the ground. Okay, question, what's the height of the ground? 0. Does it make sense to have negative heights? No, we're gonna cut it off at 0. Okay, if we have negative, our equations are going to be able to give us negative numbers, but it's not going to make sense in the context of the problem. So negative numbers, that means like below the ground, we're not going to worry about those. Okay. So what's happening is we are sending something into the air with initial velocity. So think of kicking a soccer ball. Okay, we're going to kick a soccer ball. I know, right? We're going to kick a soccer ball at an angle so it goes up in the air, okay? There are times when you're booming the ball that you want it to go in the air, not on the ground, okay? So it's going to have an initial height. When Hank kicks it, he's going to kick it with some force. so that it has initial velocity, okay? Now, if Hank's kicking it off the ground, our initial height is 0, okay? If we switch to baseball, okay, if we hit a baseball or throw a baseball, same thing, we're gonna throw it, we're gonna hit it at some sort of an angle, it's gonna have velocity, but we'll have an initial height of maybe 3, 4, 5 feet off the ground, depending on if you're hitting or throwing, okay? These are the situations we're going to analyze, okay? So what we're gonna need to be able to do, we're gonna need to be able to take a scenario and write these equations and then use these equations to answer questions, okay? If I ask you for when refers to what? Time. If I ask for when does this happen, we're solving for t, okay? How far? That would be we're solving for x. How high? That would be we're solving for y. So we need to separate out the x is horizontal, the y is vertical, okay? So let's go ahead and talk about this scenario right here. A football is kicked at an upward velocity of 30 feet per second at an angle of 55 degrees. And we're not going to worry about air resistance, okay? Write down what you need to so this makes sense when you go back and look at it in your notes. Okay, so 30 is representing our initial velocity. 55 degrees is representing our angle. What's our initial height? Our initial height is 0. We're kicking it from the T. Okay. Okay, so we're gonna write the parametric equations that model this situation. So first of all, for x, we need to take our initial velocity times the cosine of our angle, and that is our coefficient for t. Then for y, we have negative 16t squared plus 30 sine of 55 degrees t plus our initial height is 0, so we technically don't need to write that. Okay, so here's our set of parametric equations that model the situation. Okay, so if I plug in 1 for t, this would give me how far down the field the ball has traveled after 1 second. This would give me how high the ball is in the air after 1 second. Okay, let's go ahead, since I've taught you how to use your calculators, let's go ahead and put this into our calculators, okay? So x is 30 cosine of 55, right? T, and y is negative 16 t squared plus 30 sine of 55. Ugh. What did you do? Are you in? Go to y equals, go to your y equals. No. What? Go to window. Go to hit Zoom 6.
I did better.
Go to y equals.
Mine
Is that exactly what you have? 30. I mean, I did put the multiplications.
So go to window and make your T step 0.1. This T step, if your T step is like 7, that's a problem. Make it like 0.1 and see what happens. Is that better? Yeah.
Wait, why does yours? Is the window bigger?
Probably.
Yeah.
Mine is forever draft.
All right, now can we see the whole thing? No, so I'm gonna go to my window and I'm gonna make my X max, I don't know, 30. Oh, whoops. Hey, look, there it is. Okay, so this is what's happening. The ball is being kicked from the ground and goes. And what's happening here? It hits the ground, okay? Does the ball go through the ground? No, our equation does, but the ball doesn't. Okay. All right. Let's worry about answering some questions here. Okay. I want to know, when will the ball hit the ground? So first of all, we need to decide which one we're working with. Okay, we're done with the graph. We're done with the graph. Okay. When will the ball hit the ground? Am I asking you to work with the horizontal or the vertical equation? Vertical. And what is the height of the ground? 0. So I'm asking you to plug 0 in for your y.
Make sure you got a Coke.
Oh, I give you a hug right now. Thank you so much. These are the little things in life, people. Thank you. What? These are pretzels. Okay. I get what you're saying. Okay, so we're gonna put 0 in for y and we need to solve for t. Now, luckily, we didn't have our initial height, so we have 2 terms and both terms have what in common? Ah, so what can we do? We can factor out the t. We're doing this. So t equals 0, duh, we knew that. Or negative 16t plus 30 sine of 55 degrees equals 0. Okay, so I am going to subtract 30 sine of 55 degrees over and then divide by negative 16. This is when you use your calculator. Eric, how much time does it take? Did you put 30 sine of 55? So press second off. Okay. Did we get this? Do we get this? Make sure you close the parentheses for sine of 55 before you divide by the 16. Hey, did you get it? Okay. So now let's answer this. How far does the ball travel horizontally? So first of all, which equation do we need to work with? X. Okay. Second of all, I'm looking for how far. So I need to plug something in for t so I know how long x is. What do we plug in for t? T, we plug t in for t? Yeah.
1.5.
Okay. We know that the ball hits the ground at 1.536. Okay, so it stops being in the air when it hits the ground. So we can plug in 1.536 in for t. I want an answer. Yep. We need labels. Okay. Okay, so 26 feet. Let's think about this. In yards, how many yards would that be? Okay, so maybe this kicker was trying to do an onside kick. No. I'm guessing they were trying an onside kick because how far does an onside kick need to go? 10 yards, but it can bounce 10 yards. So he kicked it 9 yards and then hopefully it's going to bounce at least 1 yard and they'll get it. Okay. If you don't know what an onside kick is, it means nothing to the problem. Nothing. All right. At what time will the ball reach its maximum height? We have a parabola, yes? What is this called right here? The vertex. The vertex will always be where our ball is at its max height. Okay, I'm asking you for what time. Now, some of you are thinking, well, it's just halfway through. In this scenario, yes. But in this scenario of I kicked the ball, like let's say somebody's punting the football, and so the initial height is like 2 feet off the ground. That would not be the case. So every time, regardless of initial height, we can go back to our algebra 2 ways. We can find our vertex by taking negative b over 2a. Okay, so remember, if we have a quadratic equation, the coefficient of t squared is a, the coefficient of t is b. So our max height is occurring at the vertex, which we can find by taking negative 30 sine of 55 degrees over negative 16. Oh, over 2a. Thanks. Whoops. Okay, what's our time? 0.768. Is that what you're getting? If you're gonna divide by 2 times -16, you better be dividing by the quantity 2 times -16. Or actually use your fraction button so your order of operations don't get messed up. For example, if you type in, what was it? 30 sine of 55. If you divide by 2 times -16, this is not going to give you the right answer because it's going to divide by 2, then multiply by -16. Please make sure you are using parentheses in your denominator, or you are, oops, I forgot the negative, or you're using that fraction button. Okay. Find the maximum height of the football. Ooh, we know when it is the maximum height, right? So all we have to do is plug that time in. We want to know the maximum height, so we need the y equation. And we'll plug in our 0.768. And for t. Now, you have to do all of this on your own with your calculator. So if you're not doing this with us, you're really doing a disservice to yourself. Nicolette's got you. Nick, what's our max height? All right, football gurus, if we're doing an onside kick and it went 9 feet in the air, that's probably not very good. That's okay. He tried. Maybe it was practice. Now it's his first attempt. Okay, as promised, I have a worksheet for you, but I am going to go through number 1 with you. So when you get this worksheet, please read through number 1 and see if you can model the parametric equations for me. Read through number 1, please. Okay. Isaac, what's the X equation? Okay, good. Jalen, what's the Y equation? All right, so this time we actually do have an initial height of +3, okay? So a baseball is hit 3 feet off the ground, 150 feet per second initial velocity, 20 degrees from the horizontal. We have a fence 400 feet away. Will the ball go over the fence? Oh, it's a 20-foot fence. That's probably important. Okay, so what can we do? How can we prove this? And what can we do with that? Okay, so if we take this 400 right here and we plug 400 in for X, we can then solve for when the ball reaches 400. Okay, so how about you do that for me? Take 400 and divide over that 150 cosine of 20. Check your answer with your neighbor. What? Okay, 2 point what? $2.836. Oh, 8? 2.838? Sorry, I don't know where I heard the 6. I think it was Grayson's fault.
Eric did it too. It's not just.
Okay, so now we know when the ball will reach the fence. What should we now do with that? How high is the ball when it reaches the fence? Okay, so y equals -16t squared plus 150 sine of 20 degrees t plus 3. We are hoping for this to be 20 or higher. If it's higher than 20, it's going to clear the fence. If it's not higher than 20, it's not going to clear the fence. Plug it in. You're getting 19.73. So, okay. Feet. That is less than 20. No. So what do? We plugged the 400 feet away into X, solves for T. When we plugged that T value in for Y, we were determining how high the ball was 400 feet away. And since the ball is 19.7 feet away, it's hitting like probably that yellow line on the wall, but it's not going over the fence. What would it have meant if we got a negative answer here? Okay, if we got a negative height, that means the ball has already hit the ground before that time. Okay, now you have the rest of this worksheet. I do want to point something out though. Oops. Do you remember here when we set our y equation equal to 0? Well, it was nice because we didn't have an initial height. Well, what happens if all of this, take it out. What if I had an initial height? Can we factor that? No. So when you have something like this to solve, which you will on your worksheet, you will need to use the quadratic formula.